Hello everyone, welcome to my channel. So today we are going to do Leetcode weekly challenge second question, and its name is number of subarrays with GCD equal to K. So this is medium level question. So as it is medium level question, so we need to think about after reading this question and picking up the intuition what could be there. And also as it is medium level question, so surely constraint would also be somehow bigger than easy level one. So now let us get started with this question. So given an integer array nums and an integer k, return the number of subarrays of nums where the greatest common divisor of the subarray element is k. A subarray is that we already know. The greatest common divisor of an array is the largest integer that evenly divides all the array elements. So now the thing is that we are required to return the number of subarrays, right? Whose highest common divisor, that is HCF, is basic. Our HCD means we say it as GCD, greatest common divisor. So that particular thing is basically with respect to K is also the K only. So that's the thing which we are required to give here. So for that purpose, see, as we can see in this question, 1 minute. As we can see in this question means from the question statement only, they are saying that array is given to us and k is also given to us, right? And we are required a number of sub-arrays and the what was it property or yeah property of that particular sub-array is that the greatest common divisor which is there of the sub-array is elements is k. So basically, we are required to figure out with all the sub-arrays which are there in this particular array, where when we do GCD of all those elements with k, then it comes out to be k. So that's the thing which we are required to check here. And after getting those number of sub-arrays, we are required to return the number of sub-arrays of the same. So here in this, there is, so in this first example, so let us first see the, so here let us go ahead. So as the k is given as 3, right? So GCD of k and first element that is 9 and 3, that would be equal to 3 only, right? Because the highest common factor is basically that factor when we take out all the, means when we do that factorization. So after doing that factorization, whatever is common between both of them, and it is also the highest one, so that is the one which we are required to pick up. So that's why in that context only, here we are required, see we do the factorization of this 3, right? So here 3 is there, 1 is there, the factors of this, and here we are having again 3 is only, right? So here highest and common is 3 only, so that's why this particular is one of the sub-array which could be counted for our answer. So now our count would be incremented at this particular point. So now that we can see, this is I'm telling you about the direct naive approach only. Presently I'm telling about the intuition. Then we will be checking for the constraints also. Then accordingly we'll modify or not modify. That will be dependent. And then this 3 comes, right? So after checking for this particular 3 with this 3, right? So again the highest factor remains 3, right? So again we will be incrementing our count from 1 to 2, right? Then we check for this 1. So now 1 and 3 highest common factor would be 3, but GCD with that particular it won't be counted. So that's why we won't be counting this. And then 2, basically 1 and 3 GCD won't be means GCD would be 1 only, not the 3. That's the thing. So now here we will be checking with 2 and 3, right? So GCD would be 2 into 3, 6. So that won't be counted. Then we check for the 6. So for here 6 and 3 we will be getting our GCD as 3. So now 2 it becomes 3. And then at the end for 3 now it again becomes this 3 only as the GCD. So that's why now finally our count would be 4. So that is our answer. So this is how we are required to do this particular in the knife manner. Now let us check about the constraint. So as per the constraint, the length of our nums would be 1000, right? So as it is 1000 means 10 raised to power 3. And even if we do and go ahead with this solution, basically n square solution, then it will work. And then about this particular, so it was up to 10 raised to power 9, right? And we are performing divisions here, so it won't be required to have some long data structure or something like that. So that's why we can directly go straight forward with the same. So that's the thing here. So after checking about the same, now we can go ahead with the approach of this question. So if we put this question into some subparts, so the subparts would be that we are required to calculate the GCD, right? One function would be for this, and the other function would be our main function, where we will be going with two for loops, because here we are required to check for the subarrays, right? So one for loop would be our outer for loop, which will be from 0 to n, and the other for loop which would be that will be from 0 j from I to n. So this is basically that naive approach only n square solution. But the thing is that as per the constraint this worked, and that's why we can go ahead with the same. So now let us go ahead and check for the solution for the same. Basically I won't be coding it, but I'll explain you how we are required to do. So now here the thing is that this is that particular first for loop which I had earlier explained, and this is that second for loop, right? Now, next thing which we are required to go ahead with is here we at every for loop we are initializing our current GCD with 0, right? So so that we can figure out with that particular subarray if that is having that GCD equal to k or not. And then here we are calculating with our current GCD. So here we are checking this GCD is basically inbuilt function for in C++. So we are harnessing the same. And here we are putting two arguments, one is the current GCD and the nums of j, so that we can check out that while doing uh, GCD of the current number and whatever previous was stored. So if after combining both of them, are we able to get our GCD equal to k? If that is the case, then we will be incrementing our count, else we won't do anything. So that's the thing which we are doing in this particular loop, means this particular internal loop. And in the external loop, here you can clearly see that we are just initializing our current GCD because we are required to check for new numbers GCD at every time when we go to this particular. And now after all the numbers are being checked, then we will be returning our count. So that is the thing which we are required to do in this question. So here the time complexity of this particular, I've already told you that the time complexity for the same is basically, oh, this is something like this. Okay, so the time complexity for this particular is order of n square. Uh, it's order of n square, and the space complexity for the same is, well, you can see we are not using any extra space, right? So that's why the space complexity would be order of 1 only. So yeah, this was all for this particular question. And one more thing I want to let you know is that Newton School is already organizing with some of the coding contests. And the most exciting thing about this thing is that you can get exciting prizes by enrolling in the same and getting, and when you get there as the top performer. So because of that only, you can get those prizes. And the best part of all this is that you are already doing these Leetcode weekly, bi-weekly, and daily challenges and practicing more and the more contests. That is one of the most useful thing for preparing for interviews. So that's why it will be much helpful if you can. And that registration link you can figure out in the description below. And registration is free of cost. So why don't you want to practice in those contests as well? So go hurry and register for the same. So this was all for this particular video. And if you like this information, please do like and subscribe to my channel, and also do share among your friends. So this was all. Thank you.